Hi everyone, we're Data 225 Group 5. Our project objective is to apply machine learning to analyze IoT network traffic for hidden patterns and anomalies. So IoT is a network of physical devices. Anomaly detection and security are major concerns in the IoT domain. Every day, IoT devices generates lots of data, which is a huge resource for machine learning analysis. With such predictions, IoT service providers can detect problems in real time, proactively repair faulty devices, and optimize the network. As you can see here, the number of IoT devices is growing rapidly. By 2025, there are expected to be over 29 billion IoT devices connected to the internet. This growth is transforming industries like manufacturing, agriculture, transportation, and many others, but it also creates new security challenges. And most IoT devices have no built-in security. They are often vulnerable to attack. So there's where machine learning comes in. We're applying machine learning models to analyze IoT network traffic and identify patterns and anomalies that may indicate a security threat. Our project follows Scripts DM approach and delivered in Agile methodology. These are the implementation steps. For our literature survey, we selected the ones that are most relevant to our research. Compared to existing research, we use a comparable data set and achieved comparable results. This is a proposed workflow. We started from data collection and the data exploration, and after data is prepared, there is an iterative process from testing set and then model evaluation, and until we find the optimal model, and then we will deploy it. So for the data set we use is created by Canadian Institute for Cybersecurity and an institution in Canada. So it's generated by 105 real IoT devices to simulate a smart home IoT environment. Next, I'm gonna pass it to Sweta to talk about data exploration.
Coming to data analysis, after collection of data, we have performed exploratory data analysis on the dataset to understand the data characteristics. We found that there are almost 47 features, including the target, and 237,000 records. And upon analysis, there are no null values or duplicated values, showing the robustness of our dataset. And coming to and after that, we try to analyze the distribution of examples based on target feature. As you can see, the distribution is completely imbalanced. There are almost 10 to the power 5 of records for DDoS attacks, but only 100 for malware and exploits. Therefore, we have to balance the data set. And the next thing we found that there are 33 distinct classes, but these can be categorized into 7 broad categories for simplified analysis and classification. So all the DDoS attacks like DDoS, ICMP flood, DDoS, UTP flood are all categorized under DDoS attacks. For DOS attacks, similarly, DOS attacks, Midian attacks, and so on. Then we have plotted the probability density functions for different numerical features, such to understand the data characteristics and how data is distributed. Like these are some of the PDFs for for numerical features like flow duration, variance, weight, etc. These are some and next comes. Then we have analyzed attack by distribution. So we found out that there are almost 97% of attacks, while 20 attacks, but there are only 2.3% of bin attacks. The next bar graph shows the flag how flag and attacks values and attacks are related. If the flag if the flag is 0, then definitely there's high probability that there is an attack. Similarly, we continue the exploit data analysis. This is the scatter plot for attack by flow duration. And then we plotted box plots. As shown, for box plot of header length by label target. As you can see, there are many outliners in the dataset. Therefore, outliners also have to be handled. This is a box plot of variance by category of attack, box plot of duration by category of attack to understand how data is distributed. And then we plotted the correlation matrix. correlation matrix of different numerical features to understand the dependencies between features and see if there is any redundancy, which would be helpful for feature importance. Yes, going hand over to sign on.
Coming to data engineering part, as we have seen from the previous slides, there are a lot of outliers in our data set. So we have performed Z-score outlier detection to remove those outliers. So all the numerical features which are further than 4 standard deviations were considered outliers, and we have filtered them. The second step was to perform range normalization, and this was done using standard scalar, min-max scalar using scikit-learn library. And third thing was, as you have seen, our data set is imbalanced, and we have performed synthetic minority oversampling technique on training data to balance the classes. And once these steps are performed, we have moved on to modeling. We have chosen 4 major algorithms: random forest, decision tree, support vector machines, and naive Bayes along with KNN. We also did a logistic regression with L1 and L2 regularizations, but those have shown comparatively lower results. So we are sticking with these 4 models as our primary models. Coming to the feature extraction part, as you've seen, our dataset has around more than 40 descriptive features. So it's practically impossible to uh, test on all those features. So in order to extract the most important features, we have performed feature selection using multiple methods. The first method that we have chose was principal component analysis, and we wanted to account for 95% of variance in our descriptive features. So uh, using a simple PCA plot, we have come to the conclusion that top 22 components contribute to about 95% of the variance. So we have performed PCA, and we have trained our data with using 5 different models. As you can see, the logistic regression with L1 and L2 regularization, random forest, nearest neighbors, decision trees, and naive Bayes gave different outputs. All these are test accuracies. Moving on to the second method, we have used chi-square feature selection to select top 10 features. Basically, our dataset had lot of Boolean values, and chi-square feature selection works well for Boolean values or positive valued descriptive features. This was the idea to use it. And the features with higher Fisher score or lower p-values were selected. Using the top 10 features, we have modeled 6 models again: the logistic regression with L1 and L2 regularization, and the random forest, nearest neighbors, decision trees, and neighbors. These are the accuracies. Comparatively, random forest gave the better accuracy out of them all. The third approach was to use random forest feature selection. So this is a package available in scikit-learn, and it calculates the feature importance between descriptive features using mean decrease in impurity. And using this approach, the top 10 features are selected, and again we have performed modeling using the same models, and the accuracy on test data is mentioned here. As you can see, the random forest model again outperformed all other models, but the similar results were achieved by decision trees as well. So comparing with all the previous models and these models, we have chosen to go with random forest trained on top 10 features developed by random forest feature selection, and we have used this model in our deployment.
Coming to the modeling results, as they've already confirmed, they've used random forest for deploying the entire project because random forest gave us the highest accuracy when compared with all the other different models. Whereas in this slide, we can clearly see the accuracies of all the 4 different models, which is KNN, decision tree, random forest, and naive Bayes. And the other important reason for choosing the classification report instead of stating any less Yes, about that. Also, the random forest develop of number of contact total minimum size and ID. These are uh, data. These are the network which for customer collecting data and apart from that, neural network and model and of for current position, we want to build a data set. One is actually managing understand what kind. These are the reference. Thank you.
Moving on with the demo, we'll show the demo right now. As you can see, these are the examples with containing top 10 features based on random forest feature importance. So I'll just pick a random example here. So I have fed in all the values according to this particular example. As you can see, the target actual outcome is 2, which accounts for Mirai attacks. So let's see what it predicts. Once I enter all the values and ask for prediction, it shows the attack type Mirai attacks. Let's see another example. Okay, go with this one. Let's predict this one, DDoS attacks. So as you can see, the prediction for this example is 0, which corresponds to DDoS attacks, and we got the right prediction here. This is our sample demo. Yeah. That would be the end of our presentation. Thank you for joining.